So we're supposed to find the total power supplied in this circuit. So when you're looking for power supplied, you're looking at sources. Sources can be current sources and they can be voltage sources. It is possible that this voltage source might not actually be supplying power. We don't know until we find it. The current source definitely will be. So in order to find the power supplied by these things, we have several different formulas for power, but the only ones that we can really use for sources is power equals IV. So for each of these sources, we need to find the current through the source and the voltage across the source. And not only that, this one has the extra twist that our voltage source over on the right-hand side is a dependent voltage source. It depends on the current going through the 6 ohm resistor. So let me think for a second what we would want to do. So we're obviously going to be using some KVL or some KCL somewhere. And let's start with, again, there's always multiple ways of doing things. I think I will draw another current in. I will draw a current right there that I will call I. Because now I can look at this node on top and I can use KCL to say at that node the current coming in is 45 amps and the current going out is IX plus I. Now let's do KVL on the loop over to the right hand loop. So I want to draw a loop and I can make it clockwise or counterclockwise, doesn't matter. I am going to make my loop go like this. The only reason I did that is, notice I want to use IX as drawn in, and IX as drawn in is going down. So I'm just going to make my loop go down. It doesn't really matter because now my loop is going the opposite direction of I. It's going the opposite direction of one of them, so it doesn't really matter which one. So starting with the 6 ohm resistor, the voltage change across that 6 ohm resistor is 6IX. And it's positive because I'm going in the same direction as IX. Now, as I go around and I get to this voltage source over here, I'm entering into the negative side. And when I enter into the negative side, then I write this as negative. So this will be negative 2IX. Now, even though this looks like it's a current, it's not, because it's just that's just the number that goes along with this voltage source. And now as I come up to this top one, you can see I'm going in the opposite direction from how I defined I. So that means this one will be minus 2I equals 0. Or this equation becomes minus 8IX minus 2I equals 0. I also have the equation from up above that IX plus I equals 45. I multiply this bottom equation by 2. I get 2IX plus 2I equals 90. And then I'll just stack that with the top equation up here, minus 8IX minus 2I equals 0. And when I add these, I get negative 6IX equals 90. IX equals negative 15. Let's see if that matches what I have in my notes anywhere. It doesn't. Let's see. Do I have a sign wrong somewhere? Let's see.
Yeah, wouldn't it be 4ix at the top? Like, because you
Probably.
combine 6ix and negative 2ix, right? So, unless I
Thank
missed something.
you, thank you, thank you. Yeah, yeah. Don't hesitate to call me on those things because that's what I do. Okay, so that one would be 4, and this one would be 4. Right. And so this would be plus 6 and plus 15. Does that seem right?
Well, so underneath, like if you factor out the 2, wouldn't you still have like 2ix plus I, and what that equal, or did you like substitute something?
I don't know. Let me go back and see where I was. Okay, so I had 4ix minus 2I equaled 0. That was my top equation. And my bottom equation was ix plus I equaled 45. And then I multiplied the bottom equation by 2 so that I could do an elimination. So I multiplied this one by 2. So I got 2ix plus 2I equaled 90. And then I added this top equation to this bottom equation to get 6ix equaled 90. Or ix equals 15. Does that make sense, or did I do something wrong again? I think that's actually right. So what was your question about my eyes?
I see. Yeah, I just didn't notice what you had done. I see what
Okay,
happened.
okay, you see it now. Okay, so ix equals 15. So I'm going to erase some of this on my drawing here and fill some things in to see what all I know now. So I now know that this voltage source is 30. So that's 30. I have that ix is 15. That also tells me that the voltage across this resistor, the voltage across that resistor has to be 15 amps times 6 ohms, because voltage is current times resistance. And so the voltage across this resistor has to be 90. And it's 90 with the plus on top, so that's 90 up there. And I could say, if I say this is 0, that's 90. That tells me what the voltage change is also across this current source that I'm going to need. The only thing I think I have left is to get that value, which I called I. And we know that 45 equals ix, which is 15, plus I, or I equals 30. So this is 30 amps. And this was 30 volts. Okay. So now I'm ready to get the power for each of my sources here. So I want to pay attention to what direction the current is going. We have the current through the current source is going the direction it says it's going, and we had that this side was 0 and this side is 90. So this is the minus side and this is the plus side. So the power for the current source P equals IV. The current is 45 amps, that's given. The voltage is going to be negative 90 because we're going into the minus side. So 45 times negative 90 is whatever that is. $4050. minus 4050 watts, or 4050 watts supplied. Okay, now let's look at the voltage source. We have the current is coming into, my current of 30 amps is coming into the positive side, so my power will equal 30 amps times a positive 30 volts, which is a positive 900 watts. And so this is positive, so that means it's absorbed, so 900 watts absorbed. So the question asks, find the total power supplied. Well, this source is not supplying power, so I'm calling it a source, but it's not really supplying power. So what's the total power supplied? 4050. So 4050 is supplied. And then it must be the case that if 900 watts is absorbed by this voltage source, the rest of the wattages must be absorbed by these two resistors. And I could find those if I wanted to, but I don't really want to. I will if you ask me to, but okay, so any questions on that? All right. Let me save it.